Hi, this is Grover with Blue Collar Codes, the Quick and Dirty, episode 13. Going classes, going to go deeper into inheritance. If you wish to follow along, there's a link to the file in the GitHub repository in the video summary, episode 13.py. So first of all, let's just imagine that you are tasked with making a program for a burger joint so that they can keep track of their sales, and it's going to be something on their simple computer there, or an application on their phone that allows them to track their sales. So what you do is you create a class that has an entree that has all the basic features that you think are necessary that the customer requests on the that they want to keep track of. So here it's just the cost and the price. And so they're not keeping track. All they're selling is burgers and hot dogs. I guess they're all the same price. And so for you, that's fine. You would only need to track what you need to track. You're not going to do more than is necessary. However, after their sales do well and they want to go to the next level and start really keeping track of different ingredients, advance things to a cheeseburger, a double cheeseburger, add french fries, what have you, now you can update your older program by subclassing Entree. You can keep all of the same things in Entree, but let's say now you need to keep track of and add a little more functionality by adding a burger class. Now you can still subclass and use Entree as a parent class to keep all of those features simply by using that syntax where you're using class and then class name for the sub, and then you're putting in parentheses in the order you wish inheritance to work of the parent classes. And here you just have one, so it's Entree. And then here it's pulling all of the constructor and then these two methods. It'll still be usable when you create instances of the burger class, but now you have access to all of these other methods that you needed to define. So now you're actually going to keep track of ingredients here. But you're still just going to be creating instances with just the cost and the price. So here I have some examples. When I hit play or run on this program, you'll see some of these things print out, just showcasing that when you call or create an instance of the burger, you still need to define or utilize the entrees constructor even though you didn't redefine it. So it'll error out if you don't use these or input these two values because the constructor on entree is still required. So just showing you that it did inherit it from entree even though you didn't define it in the burger class itself. And then just showing you that you can utilize the new methods that you created and showing you that they do indeed work and update price and change things as you go. So now a further example would be using multiple parent classes, and so you will just have to think that the order does matter. That's the main thing that I want you to remember from this video entirely, is just the order of inheritance matters. So the way you're placing these parents does matter, and that goofy things will happen, especially if, say, the method you end up calling on the advanced burger only exists on entree, or on say a grandparent of entree if there's a very large, deeper structure here. And so something we'll get into in the more advanced classes or episodes is why this is good practice, and when you're going to redefine a constructor in a subclass, why you would want to call the superclass's constructor so as to keep the code unbroken. It's just better practice this way. We'll get deeper into why that is, but that is something that you can do to reutilize that entree constructor. So we're going to go a bit into a deeper example now, and that'll showcase a bit more method resolution. I apologize in advance that it's going to be very difficult, although there's no easy way to really truly define this. I could have made it much more simplistic, but I'm assuming that if you're truly interested in this, it'd be definitely a good idea to run this, to pull this file from the repository and run this, just so you can then track and trace where all these methods are being called from, which instance leads to which actual method. And what I mean by that is an instance has its own namespace, and so it first searches on the instance, then it searches on the parent class, then it'll search on the grandparent class, and then go in order. And so here I've defined a grandparent that has all of these methods and a constructor. And I'm putting prints here and having these text lines here to showcase when I hit run where the methods are actually being resolved to. So which class itself is where the method is being run from. And that's one thing you need to remember. That is how inheritance works, is you will call a method 1, say, on a child class that inherited from parent 1, and it would resolve to parent 1 if parent 1 was the first superclass. And so here you really have to take a while to look and memorize to really get a good idea of what's going to happen here. But just know right now that I kind of goofed around with these to add additional methods on some parents. To say on some methods I'm having it call and return the grandparents method. So on some of these I have a constructor. On others I'm going to be calling up a different parents constructor or a grandparents constructor. And then I have, say, 2 different grandparents. So one grandparent here, and it'll all come out in the wash here in a few examples of trying to trace what is happening. So you have children here where I'm defining their inheritance order in different ways and different patterns. So just note here parent 1, 2, 3, 1, 3, 2, 2, 1, 3, 3, 2, 1, and then parent 4. And parent 4 inherits from other grandparent first, then parent 3. So it's just showing you a bit of how convoluted and complex this inheritance structure can be, especially if they're not as simplistic as this. Granted, you're probably not going to be simply naming things method 1 all the time, but it's just showing you how you can utilize things from grandparents like ages past still just by utilizing the MRO. And so I'm going to hit run here and just try to trace a few of these for you, which I've also outlined here in the text. So just with the comment lines here, you'll see since child 3 inherited in this order, so where are these methods resolving? So child 3, so it'll call method 1, and it'll get it from parent 2. And then method 2 from parent 1, method 3 from parent 3. And that differs from all the other children simply based on the inheritance search. Oh, I gotta hit save whenever you type stuff. Alright. So the one I'm going to go over with you is just child 5, since it's more unique than these others. So child 5 inherited from parent 4, and parent 4 inherited from other grandparent and parent 3. So now when I create child 5, so right here in this, when I do this, it's going to, this is the constructor, right? So I just created C5, which is an instance of child 5 with the name there. And so this is where the constructor was called. So knowing, now we can go to child 5. So there's no constructor on child 5, so it didn't resolve there. But you do have parent 4. And so now I have to find parent 4. There's no constructor there. But then parent 4 inherits from other grandparent and then parent 3. So I need to find other grandparent, and here you find the constructor, and that's the reason you have other grandparent constructor. So now we'll go down again, and I'll show you. So I called method 1. So again, we can go to child 5, doesn't have a method 1, so now let's look at parent 4. Parent 4 doesn't have a method 1, so we have to look at other grandparent. Other grandparent does have a method 1, and so that's where you have other grandparent method 1. Now we'll do the next method, method 2, but you can tell already that all of the other methods should be located on parent 3, simply because other grandparent only had a constructor in method 1. Now let's see what happens when I change this and I could do a constructor here. And then we might as well, so that's at parent 4. So let's see what happens now after I save and I run this again. So theoretically, this should now, instead of saying other parent constructor, it would say nothing because I didn't print anything here. But let me print something here. So saved, running it again. So as you can see, now it found that constructor on parent 4. Even though other grandparent has a constructor and parent 4 has a constructor, right? So let's do this, however. Now I want you to see, if I delete these two constructors, it should default then to parent 3 constructor, and I'll print there too. So running again, so now it changed to parent 3 constructor. So that is a brief look into inheritance, but it should be pretty enlightening how complex things can get, but how powerful inheritance can be when you're utilizing it properly. But it can be a bit cumbersome and definitely takes some foresight and prior thought if you wish to design a good layout for your class structure. So again, this is Blue Collar Codes, quick and dirty, Grover. Thanks for joining.